Today we're going to talk about the neuroscience of learning, which just refers to the science of how the nervous system is related to learning and behavior. We're going to go through a quick presentation to illustrate some of the concepts that were in the chapter, and also try and think about how we can apply some of these concepts to our instruction. The chapter focuses on the central nervous system, which refers to the brain and the spinal cord, and you can see that depicted here on the left. The central nervous system is responsible for voluntary action, so both thinking and acting. It's composed of billions of neurons and glial cells, although neurons are going to be our main focus as they send and receive information throughout the body. Sensory information is transmitted through synapses, which are the connection points between neurons. Here you can see an illustration on the right of a neural network with the illustration of the messages which are lighting up and traveling between the neurons. The brain is composed of different areas that all provide key functions. So on the left, you can see an illustration showing the different areas of the brain, and the right is another illustration of the brain, but noting the key functions responsible in each area of the brain. But really what we're interested in is the cerebral cortex, which you can see here on the left. It's the front area of the brain, which processes sensory information and is the area involved in learning, memory, and the processing of sensory information. In addition to the different brain areas, the brain is also organized in two hemispheres. You can see a depiction here on the right, illustrating that the left is responsible for analytical thinking, while the right is responsible for spatial, auditory, emotional, and artistic processing. However, the brain works together. For example, the left hemisphere is central to reading, while the right is critical for interpreting context and meaning, so comprehension. And the reason we care about brain anatomy and cells is because learning, from a neuroscience perspective, is building and modifying neural connections and networks. So we do need to understand the role of sensory inputs in neural transmission to really understand how learning happens in the brain. Information is registered as a sensory input and is either discarded or channeled into working memory. The information is sent as a neural perception of that input, so the neural equivalent of the signal is either ignored or channeled into working memory for further processing. In the example you see here, the person has burned their hand, and the sensory input of pain is registered and channeled through the neural network as the perception of pain to the working memory, where it'll be further processed. And it's great to learn how the brain works, but how is this important to us as educators? Well, it's important because we're constantly bombarded with stimuli, so our brains are very good at filtering out the noise. As instructors, we want to ensure information gets directed into working memory so that students can further process new knowledge, and so we have a better chance of getting that information integrated into long-term memory. Are there ways we can aid this process through our understanding of how the brain works? The answer to that is yes. On a very basic level, importance, novelty, and intensity all attract attention. While we don't want to scream our lessons or make everything bright and flashy like it's on the screen here, we can use our understanding of neuroscience to create bright and novel visual displays for our students. In addition, we can support processing and working memory and integration into long-term memory by managing the cognitive load of our students. As noted previously, the brain receives sensory information and either ignores these signals or transmits them to working memory. However, the brain has two separate sensory channels, one for verbal material and one for graphic material. Each channel is limited in the processing capacity and can easily be overloaded with too much extraneous information. Here we can see the instructor is saying the word apple over on the bottom left, and a picture of an apple is also presented. You can see here on the top left. The stimuli can both be processed at the same time, which takes advantage of these dual channels. However, what if we write the word apple on the board and show the picture of the apple? Instead of hearing and seeing the apple, we are seeing the apple and seeing the word apple. Our brain processes visual text through the visual channel, so when information is more complex, we run the risk of overloading the visual channel. As you see here, both the picture of the apple and the word apple are being processed through the visual channel. In addition to cognitive load, visual attention is limited. When the eyes are looking at text, they cannot be looking at the graphics and vice versa. However, by presenting explanations verbally, the explanations are processed in the verbal channel, while the graphical information is being processed in the visual channel. While you might have felt overwhelmed reading this chapter this week, thinking, how is this relevant to me? We can derive some instructional implications from neurological research. This is one example where we've learned that, when possible, limit the amount of text you use in favor of providing clear graphical examples. The brain can process this at the same time as verbal information, reducing cognitive load and allowing for deeper processing. How much easier was it to process this presentation compared to reading the chapter? How much of that has to do with the audio narration and the graphical representations? And can you think about any examples when too much text inhibited information processing for you? I can think of many seminars where presenters had blocks and blocks of text, and it made it really hard to process the information being delivered. Think about really effective presentations you've seen, and think about some of the qualities these presentations had.